Okay, so we're going to talk about 9.8 instead of sort of the graphic parts of stats and data, histograms, frequency tables, stem plots. We're going to talk more about the algebra behind it. We're going to talk about measures of center, the 5-number summary, box plots, standard deviations, all this other stuff. And we're going to fly through like the first half of this because quite frankly it's stuff that you already know. You know how to find the mean. The big thing here is understanding the notation. X with the line over it, that's called X bar. Okay, that stands for the mean. Okay, so when you see that symbol in your calculator, that means the mean. I'm not going to make it, you know how to find the mean. Okay, add the numbers up, divide by the total number. Median, median is the number in the middle, but you have to arrange them in order first. Make sure you do that, although you probably won't have to with the calculator. If you get stuck without a calculator, make sure you arrange the terms in order and then apply that. And again, median, you can find median. Mode, you guys know what mode is. Okay, the only couple things I want to point out. Example 5, you have a frequency table. So it says that teacher gives a 10-point quiz, records the scores in a frequency table. Find the mean, the mode, median, and mean of the data. Well, the mode is easy. Okay, it's the frequency, the highest frequency. Well, the highest frequency is right here. Okay, 7 came up 8 times, so the mode is 7. Now the mean and median, what you can do is in your calculator, you can do your one variable stats. Just make sure that you have to put, so for your L1 column, you would have to put 10 in twice because it shows up 10 times. 9 2 times because it shows up twice, and so on. Okay, and then use your one variable stat. Okay, when you're dealing with a weighted mean, this is a little bit different. Okay, so at Marty's school, it is administrative policy that the final exam must count 25% of the semester grade. If Marty has an 88.5 average going into the final exam, what is the minimum exam score needed to earn a 90 for the semester? So what we want to do is, okay, the final is 25% of the grade. That means 75% is the quarter grade, or semester grade, excuse me. Well, I don't want to even say it that way. It's the rest. It's the rest. Okay? Now, so that means that 88.5 is going to be multiplied by 0.75 because 75% of the final grade is everything leading up to that, to the final, plus X, because we don't know what score he needs to get a 90. It's going to be X times 0.25 because 25% of the final grade is the final. Okay, now on the bottom, we have to divide by the sum of the probabilities, okay, which equals 1. Okay, now, whoops, sorry, hang on. Now, that equals, okay, that equals 89.5. Okay, because if you round up 89.5, you can still get a 90. Okay, so he's looking for the minimum score. So we'll use 89.5 total because 89.5 and above would get you a 90. So the bottom is 1. Okay, 88.5. So here's what we have. We have 88.5 times 0.75 plus 0.25x equals 89.5. Okay, so it equals 1. Okay, so we want to subtract whatever 88.5. Well, here, let's figure it out for crying out loud. I'm at a church. That's all the commotion you hear behind you. So 88.5 times 0.75 is 66.375. So you solve this, and x comes out to be 92.5, which is 93. Okay, so when you're dealing with weights, the final exam is 25%. So he needs to get at least a 93 to get a 90 for the semester. Okay, 5-number summary. Minimum, Q1, median, Q3, maximum. Interquartile range, okay, is you just take Q3 and subtract Q1. Now, Q1 is the median of the first half of the data. And then Q3 is the median of the second half. Okay? So your 5-number summary, this is actually what you're going to use to do a box plot. Okay? So, for example, 7, okay, we have our life expectancies again. Okay? So what you want to do is use your one variable stats. Okay? So for the males, if you put it in the calculator, matter of fact, what I'd like you to do is put those into the calculator. Okay? All right? You have to scroll all the way down in your calculator. Okay? Then what I want you to do is find the range of the males and then the range of the females. Okay? Then I want you to find the interquartile range for both. Okay? You guys can easily do this with your calculators. I'm not going to waste time doing it. Okay? Now, what I want you to do, okay, is figure those out, and then tomorrow in class we'll talk about what to say when we compare the spreads. Okay. Outliers. Okay. Outliers. A term is considered an outlier if it is more than 1.5 times IQR below the first quartile or above the third quartile. Now, what we want to do here, okay, is from Roger Maris's home run data. Okay, I believe, not sure if we figured that out or not, but we have that table. Okay. Wait, hang on. So your 5-number summary, okay, is 5, 11, 19.5, 30.5, and 61. Okay, so what that means, this is the minimum, that's Q1, that's the median, that's Q3, and that is the max. Okay, so your interquartile range is 30.5 minus 19.5, which is 11. Now, here's the thing. When we do this, we have to set up the range of values that establish where the outlier could be. If I do Q1 minus 1.5 times the IQR, that'll set the lower bound. If I do Q3 plus 1.5 times IQR, that'll set the upper bound. So Q1 is 11 minus 1.5 times, oh, whoops, I messed up the IQR. Sorry, distracted by God. I'm in a church. 30 minus, oh, there we go. 19.5 is the interquartile range. Okay, so I have 11 minus 1.5 times 19.5. So 11 minus 1.5 times 19.5. No idea how awkward this is. Negative 18.25. So that's the lower bound. Now, Q3 is 30.5 plus 1.5 times 19.5. Okay? So I get 59.75. Now, the criteria for the outlier, so they're asking, is 61 an outlier? So in other words, does 61 fall between these two numbers? If it doesn't, then it's an outlier. Well, 61 is greater, is 59.75. So 61 is an outlier. Okay. The standard deviation. Now they give you this big fancy formula, but you don't need to know it because you're going to use the calculator to find it. Important, if we define the deviation of a data value to be how much it differs from the mean, okay, then the variance is just the mean of the squared deviations. Okay, so really what this means is standard deviation is, okay, what is our difference from the mean? Okay, on either side. Okay, so if our standard deviation was, say, 5, that means that based on the mean, the one standard deviation would be 5 on either side, plus 5 or minus 5. Okay, so when we do standard deviation, okay, we're going to use our one variable stats. Use your calculator. Okay, so x bar says estimate the mean and standard deviation for the weights. So x bar is 87.49. Okay, and then now we are going to use s sub x. Okay, because we're only doing a sample, and it says based on the sample. So because it's a sample, we have to use the sample, not the whole population. So that s sub x is, I believe, 3.51. Okay? Now it says, are these measures useful in this case, or should we use the 5-number summary? What we're looking for is a normal distribution curve. Okay? And yeah, okay, we'll talk about that next. Okay, but graph a histogram of the data. In this problem, use your x scale as 2. Okay? Now, what you're going to see, roughly, is you're going to see a histogram that looks something like this. I'm just guesstimating. I have no idea. But what you can see is it sort of mimics a bell curve. That is the normal distribution curve. Okay? So what that means, there are no outliers. So that the mean and the standard deviation are accurate. We don't have to go to the 5-number summary. If I got a histogram that didn't look like that, then I would have to use the 5-number summary. Okay? Okay. 68, 95, 99.7. Rule. If the data for a population are normally distributed with mean U and standard deviation, whatever that is, then approximately 68% of the data lie in one standard deviation. So basically this is what it looks like. Here, let me just do this. So here's x bar. Here's one standard deviation. So that means 68%. Okay, 68% of the data lie in that area right there. Now, 2 standard deviations. Now, within 2 standard deviations, that's 95% of the data. and then 3 standard deviations. Okay? Now we've basically got the whole thing.
Okay. See you, buddy.
Bye-bye. Take care. So 99.7% fits in the whole thing. So it works its way out. Okay? So typically what happens is we talked about the normal distribution curve. Okay? Now here's the mean. All right? So the mean cuts this section in half. So this would be 34%. 34%. Okay? Okay, we're adding on another 27% to get to the 95, so that's 13.5, 13.5%. Okay, and then another 4.7%, so this would be roughly 2.35% and 2.35%. Okay, what a normal distribution means, guys, is the data packs closely to around the mean. It packs closely in this area, and then it kind of fades out as you get lower or higher. Okay, so it says, based on the research data presented in example 10, would a loon chick weighing 95 pounds be, or 95 grams, be in the top 2.5% of all the hatched loon chicks? Okay, so here's what you do. All right, so it's X bar. Now, when you look at this graph, this is the area that they're looking at. Okay? This is the area they're looking at. So that means it has to be more than, that means that in this area, okay, this means we are more than 2 standard deviations. That's what the top 2.5% means. So how do we find that? Okay, what we do is we use this formula right here. I know you can't see it, but it's X bar plus 2 times the standard deviation. So X bar was 87.49, I believe. Yes. Plus 2 times the standard deviation, which was 3.51. So that is 94.51 grams. Now the question is, okay, the question is, that is the upper limit. Okay, so anything above this number would be in the top 2.5% because we've established the border. So in other words, this number right here would be 94.51. So anything above it would be in the top 2.5%. Well, 95 was the question. Well, 95 is greater than 94.51. So it's in the top 2.5%. Okay? You're going to be doing a ton with standard deviations. I apologize for the length of the video and the interruptions. I'm in a church. My sister has practice for her singing group, so she sings as well as dances. So if there's questions, we can go over it. You'll have all class time to work. I just wanted to give you the brief kind of synopsis. So that's 9.8.